Let x of omega be a non-negative random variable defined for all omega in the sample space omega. We define the Lebesgue integral as the integral over the sample space omega of x of omega with respect to the probability measure p. First, we partition the range of values, the y-axis, into subintervals defined by points 0 equals y0, is less than y1, is less than ... is less than yn. The norm of the partition, denoted by the norm of pi, is defined as the length of the longest subinterval, yk plus 1 minus yk. For each subinterval yk to yk plus 1, we identify the set of outcomes ak that map to these values. Ak is the set of omega such that yk is less than or equal to x of omega, which is less than yk plus 1. Note, instead of finding a maximum or minimum height like Riemann, we find the pre-image set. Using these sets, we define the lower Lebesgue sum, ls minus sub pi. This is calculated by taking the lower value yk and weighting it by the probability measure of the set ak, ls minus sub pi of x equals the sum from k equals 0 to infinity, of yk times the probability of ak. Finally, as the norm of the partition approaches 0, and the partition covers the entire range 0 to infinity, this sum converges to a limit. This limit is the Lebesgue integral.